Isang makulimlim ngunit magandang umaga sa lahat. Patuloy ang pagbuhos ng ulan sa iba't ibang bahagi ng bansa. Kaya mahalaga na nakatutok sa update sa lagay ng panahon upang hindi mahasal ngayong araw. At hatid ng DOSTv at DOST Pag-asa ang weather update, plus science and technology news para always on the go ang lahat. Ako po si Jel Miranda, ang inyong ka-online at ka-forever. We welcome you to DOSTv, your most comprehensive real-time authority on the latest weather updates. Dahil weather lang ang laging nandyan, tag-araw man o tag-ulan, hindi nang iiwan kahit sino ka man. Remember that folks, it's DOSTv, reporting live from Pag-asa Weather and Flood Forecasting Center. Ang DOSTv ay mapapanood ninyo Mondays to Fridays, 11 a.m. to 12 noon, dito lang sa www.dostv.ph. At live na rin po tayo sa Facebook at facebook.com/DOSTVPH. Kaya makisabay na rin sa live streaming namin. May future ang nuclear technology sa bansa natin. Yan ang good news na dapat nating ika-excite dahil time will come na pwede tayong makipagsabayan sa ating mga karatig bansa in terms of nuclear technology. At maliban dyan, matutunghayan din natin kung paano minemaintain ng DOST ang ating safety sa oras ng kalamidad, lalo na kapag may lindol. All that and more para sa episode natin sa araw na ito. Pero bago yan, alamin muna natin ang magiging lagay ng panahon for today. Heto ng ating Pag-asa correspondent, Mr. Benison Estareja para sa ating ulat panahon.
Thank you, Ms. Jel. Good morning sa iyo at good morning din sa ating mga viewers ng DOSTv. Ngayong araw po ng Miyerkules, meron pa rin po tayong tail end ng cold front na siyang nakakapekto dito sa northern and central Luzon. Kung mapapansin po natin, ito yung indicated by the blue lines na isang straight line po. Ito po yung boundary ng amihan or northeast monsoon at ng easterlies o yung hangin na nagmumula sa Pacific Ocean. So ang tendency po ng tail end ng cold front, magdala ito ng kaulapan na may kasama mga mahina hanggang katamtamang mga pagulan or minsan ay lumalakas din ng mga pagulan. Base po sa ating weather ngayong araw for Luzon, kung mapapansin po natin, nakakonsentrate yung kaulapan na dulot ng tail end ng cold front dito po sa mga lalawigan ng Aurora and Isabela. So asahan po nila ngayong araw, moderate to occasionally heavy na mga pagulan na posible magdulot ng flash floods dito sa mabababang lugar o malapit sa tabing ilog at posible rin ng landslides dito naman sa mga matataas na lugar. Dito naman po sa natitirang bahagi ng Cagayan Valley, gayon din sa Cordillera Administrative Region, Ilocos Region at natitirang bahagi ng Central Luzon, asahan po ngayong araw, maulap din ang kanilang kalangitan na may kasamang light to moderate na mga pagulan at pagkidlat, pagkulog. Dito naman po sa Metro Manila, gayon din sa Calabarzon and sa Bicol Region, bahagyang maulap hanggang sa maulap ang magiging kalangitan ngayong araw. Possible din ang mga isolated thunderstorms at mga mahina hanggang katamtamang mga pagulan na bahagyang epekto ng tail end ng cold front. Habang dito naman po sa Mimaropa, asahan ang fair weather or maaliwalas sa panahon ngayong araw, maliban pa rin sa mga panandaliang buhos ng ulan. Dumako naman po tayo sa ating magiging temperatura ngayong araw. Dito sa Luzon, sa Metro Manila po, 25 hanggang 31 degrees Celsius ang temperatura. Dito naman sa Baguio, maglalaro mula 15 hanggang 23 degrees ang temperatura. Sa Tagaytay City naman, 21 hanggang 29 degrees Celsius. And then finally sa Puerto Princesa, 25 hanggang 32 degrees Celsius. Dumako naman po tayo sa ating magiging weather for Visayas and Mindanao. Kung mapapansin po natin, mas maganda ang panahon sa Visayas and Mindanao kumpara dito po sa Luzon. So asahan po natin ngayong araw, especially dito sa may Mindanao, fair weather or maaliwalas sa panahon ng mararanasan at dito rin sa may Central Visayas and parts of Eastern Visayas. Posible na maging maulap lalo na dito sa may eastern portion of Visayas and Mindanao dahil po yan sa umiiral na easterlies o yung hangin naman na nagmumula sa Pacific Ocean. At posible rin ang mga isolated rain showers or thunderstorms na mostly nga ay sa silangang bahagi ng Visayas and Mindanao. Dumako naman po tayo sa ating magiging temperatura for Visayas and Mindanao. Sa Metro Cebu and Iloilo City, 25 hanggang 32 degrees ang ating temperatura. Dito naman sa Metro Davao, mainit pa rin 25 hanggang 33 degrees at mainit din po sa Zamboanga City, nasa 24 naman hanggang 33 degrees Celsius. Sa ngayon po, wala pa rin tayong gale warning, pwede pa rin maglayag ang anumang uri ng sasakyang pandagat sa ating mga baybayin. At wala rin po tayong namamataan na low pressure area or bagyo man sa loob or maging sa paligid ng ating Philippine Area of Responsibility. Dumako naman po tayo sa ating magiging sunset and sunrise. Katulad po kahapon, lulubog si Haring Araw sa ganap na 5:24 ng hapon. At muli naman itong sisikat bukas 5:58 ng umaga. At mula pa rin dito sa Weather Forecasting Center ng DOST Pag-asa, ako po si Benison Estareja, reporting for DOSTv.
And for an exclusive content na dito niya lang sa DOSTv makikita, here's Mr. Danilo Flores for our flood and water level advisory.
Magandang umaga, Jel, at saka sa ating mga taga-subaybay sa DOSTv. Si Danilo Flores mula sa Pag-asa HMD mag-uulat sa mga kalagayan ng ating dams ngayong umaga dito sa Luzon. Unahin na natin, Jel, itong Angat Dam dito sa Pampanga River Basin sa may bandang Bulacan. In past 24 hours, bumababa siyang tuloy-tuloy ng 18 centimeters. Papansin natin, past 3 days, bumababa siyang bahagya dahil wala ng pag-ulan. Nasa level niya ngayon na 204.9 meters. Ang ating San Roque Dam dito sa Sagno, bumababa siya tuloy-tuloy, bahagya, 9 centimeters in 24 hours. Past 4 days, tuloy-tuloy ang kanyang bahagyang pagbaba. Sa level niya sa ngayong umaga, as of 6, 282.46 meters. Ang ating Pantabangan Dam, ito yung sa taas ng Pampanga River Basin sa may Karanglan, Nueva Ecija, patuloy sa kanyang pagtaas. Past few days, bahagyang pagtaas. Sa level niya ngayong umaga na 206.09 meters. Ang ating Magat Dam dito sa Cagayan Valley, sa Isabela, tuloy-tuloy sa kanyang pagbaba for the past few days. Bahagya ang kanyang pagbaba sa level niya ngayong umaga na 190.16 meters above sea level. Ang ating mga ini-issue as of this morning, Jel, napapansin natin na may mapag-ulan dito sa Central Luzon. Itong mga past 24 hours o past almost 2 days, meron tayong in-issue na General Flood Advisory sa Region 2, Cagayan Valley, kung saan may natatalang mga pag-ulan. Sa Region 3, dito sa may bandang Aurora, saka sa Region 4A sa Calabarzon, Region 5 sa Bicol, Region 8 sa Eastern Visayas. Nakikita natin dito sa mapa na halos nasa Eastern Seaboard yung kanyang winawarningan na binibigyan natin ng flood advisory. Ibig sabihin nito, ito yung effect ng northeast o kaya yung sinasabi nilang tail end of a cold front. So mula dito ulit sa Hydromet Station ng Pag-asa, si Danny Flores po nag-uulat.
The Greater Metropolitan Manila area has a long history of natural disasters and extreme weather events. Following the calamity of Typhoon Ondoy in September 2009, which caused about 500 deaths and damage of about 41 billion pesos, the Greater Metropolitan Manila Area Risk Analysis Project was begun. Covering the 16 cities and one municipality of Metropolitan Manila, as well as parts of Bulacan, Cavite, and Rizal, the study looked at the hazards of flood, wind, and earthquake. The project is a collaboration between the technical agencies of the Government of Philippines, supported by the Government of Australia Aid Program and Geoscience Australia. The aim of the project has been to give a much clearer understanding of the risks from natural disasters, of where the risks are greatest, and of how the dangers can be reduced. This analysis identifies 3 main types of potential risk: flooding in the Pasig-Marikina River Basin, severe winds associated with tropical cyclones, and risks from damaging earthquakes from the West Valley Fault. Natural hazard risk analysis involves understanding the relationship between a hazard, the exposure or elements at risk, and the vulnerability of those elements. Risk can be expressed in terms of physical damage, economic loss, or the number of people killed or injured. Information was developed that first built an understanding of how people live and work in the Greater Metropolitan Manila area. The study area included the low-lying areas along Manila Bay and Laguna de Bay, the flood-prone Pasig-Marikina River Basin, the elevated areas in Rizal Province to the east, and the West Valley Fault, which passes north to south through the metropolitan area. LiDAR, light detection and ranging, was the first major set of data to be collected. An aircraft flying over the greater metropolitan Manila area used a special laser scanning device to measure the profile of the landform and the heights of such features as trees and buildings. From these measurements, a digital elevation model, or DEM, was constructed. The model gives us an overview of an area that is home to about 12 million people. But where do they live? Where do they work? And what makes them vulnerable to natural hazards? Using the best available data from many sources, a picture of the built environment is developed. Of building density, of population density, of the current land use, of building heights, and of the complex mixture of the age and type of buildings that are present across the metropolitan area. All of the information about the characteristics of exposure that are needed for risk analysis have been gathered and organised into a spatially enabled exposure database. To estimate the vulnerability of buildings exposed to natural hazards, engineering models for different building types were developed. Not all buildings will experience the same level of damage when they are exposed to the same level of hazard. For example, engineered reinforced concrete buildings will, on average, suffer less damage than unreinforced masonry buildings when subjected to the same level of ground shaking. Hence, vulnerability models were developed for different building types to characterise the average economic loss for each building type. Economic damage is complex. Low-cost buildings may be destroyed and be inexpensively replaced, but high-cost, well-constructed buildings may suffer minor damage that is relatively expensive to repair. All of this is reflected in datasets estimating the costs of damage. The relationship between wind and the landscape changes the impact of severe winds on the city. Winds increase in ferocity as they flow over hills, over ridges, and over high ground. Areas such as the open space of the airport, of Manila Bay, and of the riverbanks experience higher wind speeds than built-up areas. Knowing wind strength means knowing how buildings, billboards, and shanties will be affected. The areas of greatest damage can be seen in the mountainous regions in the east and along the escarpment of the West Valley Fault. The steep topography in these areas, combined with the presence of wooden and makeshift structures in the rural areas, are the reason for the high level of damage. Flood projections are calculated from known rainfall figures. Metro Manila has experienced catastrophic flood events along the Marikina Valley and the San Juan River and can expect more. The figures that have been calculated show that there is a possibility of a flood bigger than has been experienced in recent times. The results also show how damaging floodwaters can be expected to move through the city over a period of 48 hours, how high floodwaters will reach, and what the area of inundation will be. Damage is widespread in low-lying parts of the city and adjacent the main river systems. A particularly large damage hotspot occurs in the city of Marikina, where deep floodwaters combine with a high proportion of wooden and makeshift structures, which are easily damaged by flooding. As with winds and flood, the mapping of earthquake events can be related to what is known of land use, and physical and economic damage can be mapped according to where the most fragile forms of housing have been constructed. The population affected can be mapped, and so can the economic damage because of the land use and construction methods. A range of earthquake events were used as the basis for calculations. The hotspots, clearly seen following the West Valley Fault, and areas lining Manila Bay, both the expectation of strong shaking and the high concentration of easily damaged buildings explain this. Risk analysis is employed for locating the areas at risk and quantifying the risk posed by earthquake, severe wind, and flood. We can illustrate this with the example of earthquakes by combining information on the three parts to risk and plotting the quantity of risk. By comparing formal settlements, major commercial areas and informal settlements, we can see how the measure of risk changes. The factors considered are hazard, which describes the likely intensity of an earthquake in that area; exposure, which describes the number and type of buildings that may be at risk to earthquake; and vulnerability, which indicates the expected physical damage and economic loss, which varies from high for makeshift structures to low for reinforced concrete buildings. By identifying those places at greatest risk, we can highlight areas where, for example, modifications to land development or building practices would have most value. By identifying the most at-risk areas, local government units have the opportunity to adapt their planning in new developments and identify those places which, being most at risk, will need early warning of flood danger, early intervention and assistance. The data products that have been produced by the Greater Metropolitan Manila Area Risk Analysis are free and will be readily accessible from the Office of Civil Defence and the Philippines Geo Portal. They will be provided to each local government unit, which can update the data and build their own database for planning, designing and implementing projects, mitigation activities and contingency planning. Flood, earthquake and severe winds will always be a threat to the Greater Metropolitan Manila area. The risk analysis tools help us to understand, prepare for and survive these hazards. Australia stands ready to support the Philippines in this effort. By jointly investing in building the resilience of communities to natural disasters, we can contribute to a safer future for all Filipinos.
The Philippine Nuclear Research Institute, or PNRI, is an institution of excellence in nuclear science and technology, propelled by a dynamic and committed workforce in the mainstream of national development. In line with this, PNRI aims to contribute to the improvement of the quality of Filipino life through the highest standards of nuclear research and development, specialized nuclear services, nuclear technology transfer, and effective and efficient implementation of nuclear safety practices and regulations. Panoorin po natin ang susunod na video na nagpapatunay na isa lamang ang PNRI sa mga line agencies ng bansa na walang humpay na nagbibigay ng mga improvements and innovations para lalo maging magaan at mapabuti ang buhay nating lahat.
The Philippines became a member state of the International Atomic Energy Agency, or IAEA, in 1958. The Philippines has been a solid and productive partner in the realization of the IAEA's Atoms for Peace program. At the center of this fruitful cooperation for more than half a century is the Philippine Nuclear Research Institute, or PNRI, formerly the Philippine Atomic Energy Commission. PNRI is a research and development institute and the national nuclear regulatory body under the Department of Science and Technology. PNRI spearheads the development and applications of nuclear science and technology in agriculture, health, industry, and environment to address the country's needs. PNRI scientists are developing precision farming methods using radioisotopes and stable isotope tracers such as nitrogen-15. Precision farming methods are undertaken to determine the right amount and proper timing of fertilizer application at different growth stages of staple food crops such as rice and corn. Soil moisture neutron probe and other related techniques are being used to optimize irrigation scheduling, while carbon-13 and oxygen-18 isotopes are used to evaluate and assess the effectiveness of different irrigation technologies. Results show that better practices can increase fertilizer utilization up to 70%. Appropriate irrigation scheduling can improve crop water use efficiency and minimize losses by around 25%. These will serve as bases for updating the decades-old recommended levels of fertilizer and water inputs in agricultural production. The preliminary findings are being shared to the project's beneficiaries and stakeholders, local government units in the nearby provinces and municipalities, and other farmer cooperators. PNRI scientists have developed plant growth promoters, or PGPs, from radiation-processed natural polymers such as carrageenan and chitosan. Results of initial pot experiments on mung bean and peanut showed that the PGPs from irradiated carrageenan and chitosan increased the crop yield by 200 to 300%. Field experiments are currently being conducted at the Cagayan Valley Research Center in Isabela Province with promising results. Field testing on rice sprayed with PGPs resulted in plants showing no signs of rice tungro disease infection. The field test was conducted at the University of the Philippines, Los Baños in Laguna Province. Through radiation technology and mutation breeding, PNRI conducts studies on improving the quality of adlai. Adlai is a tall grain-bearing tropical plant from the same family as rice and corn, which grows abundantly in the country and may also serve as an alternative staple food. Results of PNRI studies show that the plant height of irradiated adlai decreased by up to 1 meter, making them more resistant to lodging caused by strong winds and typhoons. Gamma irradiation can also be used to control the population of various pests that damage agricultural crops and serve as carriers of viruses and diseases. These problems are even more prevalent in tropical countries such as the Philippines. PNRI scientists previously used the sterile insect technique, or SIT, against fruit flies that infest export fruits like mangoes. The Institute later expanded its applications to help mitigate the perennial dengue problem in the Philippines. A stock colony of Aedes aegypti was established at the PNRI laboratory as a source of test insects for various experimental tests, leading to the development of SIT against the dengue mosquito vector. Around 39 nuclear medicine facilities in the Philippines are licensed by PNRI. These facilities use technetium-99m and other radioisotopes for diagnosis of the state of health of various human organs and treatment of certain diseases. Through its newly established technetium-99m generator facility, PNRI paves the way for cheaper and more available supplies of radiopharmaceuticals in the country. This facility was established with IAEA technical assistance. The local production of technetium-99m will save the medical industry up to around 20% of the average cost for imported technetium radiopharmaceuticals. PNRI has been recently licensed by the Food and Drug Administration to operate the facility. Proposals are also being considered to make technetium-99m available at subsidized costs to government hospitals and charity patients. Medical cyclotron facilities enable the local production of medical isotopes which serve as tracers in positron emission tomography, or PET imaging. PET imaging is used to diagnose various oncological, neurological, and cardiovascular diseases. The first medical cyclotron in the country was set up in 2001 at St. Luke's Medical Center as an in-house facility. With technical assistance from the IAEA, PNRI coordinated a task force composed of private and government sectors to set up the second medical cyclotron facility in the Philippines. The cyclotron was recently established by the private sector in cooperation with the National Kidney and Transplant Institute. The centralized medical cyclotron facility will allow PET-CT imaging to be more accessible to several hospitals and can even halve the cost of these procedures. This facility will further modernize nuclear medicine in the country. Aside from surgery and chemotherapy, radiotherapy is another method for treating cancer through the application of ionizing radiation. PNRI monitors about 36 radiotherapy hospitals and medical centers in the Philippines to maintain the required level of safety and security according to IAEA standards. The nuclear medicine and radiotherapy professionals, through their respective professional societies, are participating in the IAEA Quantum and Quattro projects to enhance quality of procedures and patient care and ultimately nuclear safety. Quantum stands for Quality Assurance in Nuclear Medicine, while Quattro is Quality Assurance Team for Radiation Oncology. Harmful algal blooms, also known as red tide, has always caused damage to the health and business of fishing communities and consumers alike, a problem that makes an archipelago such as the Philippines especially vulnerable. In 2005 and in 2010, IAEA designated the PNRI as a collaborating center in harmful algal bloom studies. The Institute engaged in research and development on receptor binding assay, or RBA, which has been approved by the Association of Official Analytical Chemists International in 2011 as the analytical tool for paralytic shellfish poisoning. The PNRI is transferring the RBA technology to the Bureau of Fisheries and Aquatic Resources as an alternative to mouse bioassay. In cooperation with the University of the Philippines Marine Science Institute, PNRI currently undertakes various researches on harmful algal blooms, shares its expertise, and accepts trainees from other IAEA member states. Stable isotope ratio mass spectrometry is used for analyzing the geographic and botanical origin of samples, as well as the methods and mechanisms used for their production. In 2008, PNRI established its own isotope ratio mass spectrometer, or IRMS laboratory. The IRMS laboratory facilitates many of PNRI's environmental research involving water resources and drainage basin studies, and for the precision farming project to measure fertilizer and water uptake by plants. The IRMS facility is also used for the analysis of food and other samples to determine their provenance or origin. PNRI's IRMS facility made isotope analytical services cheaper and more accessible to local researchers. The PNRI and the Bureau of Soils and Water Management, or BSWM, used the stable isotope technique to trace the sources of pollutants entering the Manila Bay from the Pampanga River Basin. The mixing models revealed that domestic and cropland sources contributed dominantly in the pollution along the Pampanga River Basin leading to Manila Bay. The Department of Environment and Natural Resources is again contracting PNRI and BSWM to replicate the study with the 3 other river basins discharging into the bay to get a complete picture of the pollution loading in the Manila Bay. The PNRI has been using radiation from the Cobalt-60 facility since the late 1980s with successful results. The Cobalt-60 irradiation facility has been used in the sterilization of medical devices, packaging materials and pharmaceuticals, decontamination of cosmetic raw materials, spices, dehydrated vegetables and herbal products, extension of shelf life of food, and quarantine treatment of fruits and vegetables. The present multi-purpose irradiation facility is now being used on a semi-commercial scale. The new 2.5 MeV electron beam facility at PNRI is capable of delivering higher dose rates, thus widening the applications of radiation processing, such as radiation cross-linking and polymer grafting. The establishment of the electron beam facility in the Philippines received financial support from the IAEA and the Japanese and U.S. governments under the Peaceful Utilization Initiative. The PNRI received counterpart funds from the Department of Science and Technology, Grants in Aid, and the national government for the facility. To help enhance the export competitiveness of Philippine super mangoes, PNRI has developed a quarantine treatment using gamma irradiation against the mango pulp weevil. Based on PNRI's research studies, a minimum radiation dose of 165 gray is enough to make the adult mango weevil sterile, providing sufficient quarantine security for the Philippine mangoes. The quarantine treatment was already published as a final rule in the United States Federal Register in October 2014. The U.S. Department of Agriculture has also recently expanded the weevil-free areas in the country beyond Guimaras Island, finally allowing more Philippine mango exports to enter the United States. In collaboration with the Bureau of Plant Industry, PNRI will also play a major role in implementing the quarantine treatment through the upgrading of its semi-commercial irradiation facility. As the national nuclear regulatory body, the PNRI formulates rules and regulations on the safety and security of atomic energy facilities and radioactive materials. The PNRI grants licenses to industrial, commercial, medical, educational, and training sectors for authorization to use, possess, produce, store, sell, transport, or import radioactive materials. The Philippines continues to participate in the international effort to address nuclear security and prevent nuclear terrorism under the Global Threat Reduction Initiative and Megaports Initiative. In support of the Megaports Initiative, radiation portal monitor systems were installed at the ports of Manila and Cebu to detect, deter, and prevent illicit trafficking of nuclear and other radioactive materials. The monitoring systems were donated through a memorandum of intent between the U.S. and the Philippine governments under the Megaports Initiative of the U.S. Department of Energy. To ensure sustainability, the European Union is donating a radiation portal monitor and other equipment for training of port operators and Bureau of Customs personnel. PNRI operates the only centralized radioactive waste management facility for low-level radioactive wastes in the country. This provides for the treatment and temporary storage of immobilized, disused radioactive sources and other waste packages for interim storage. A project on conditioning spent high-activity radioactive sources was conducted in cooperation with the South African Nuclear Energy Corporation and the IAEA. This project was undertaken to ensure safe and secure management of these sources in a long-term storage container, reducing radiation levels at the surface and eliminating the risk of overexposure and possible covert action. PNRI is evaluating a site for the final disposal of low and intermediate level wastes. The site evaluation is being undertaken with other government agencies. The Institute envisions to co-locate a near-surface radioactive waste facility with the IAEA recommended BOS facility for disused sources. The PNRI Nuclear Training Center conducts training courses, seminars, and workshops for various groups and sectors on capability building in the field of nuclear science and technology. The training courses tackle on the applications of nuclear S&T and on radiation and nuclear safety. Laboratories and facilities of the different research units in PNRI are made available to the trainees, in addition to arrangements made with other private companies, government agencies, universities, and hospitals. PNRI also conducts training courses on non-destructive testing in cooperation with the Philippine Society for Non-Destructive Testing. The PNRI Nuclear Training Center has been accredited by Lufthansa Technique Philippines as an NDT training service provider per European Standard EN 4179. The IAEA has selected the Philippines as one of the pilot countries in launching an outreach program on nuclear science and technology for secondary schools. This project is being undertaken through the collaboration of the PNRI and the Quezon City Division of City Schools of the Department of Education. The IAEA developed a compendium of resources and activities for use by high school teachers and students. The compendium will be tailored to the flow of DepEd's K-12 basic education curriculum, such that it may touch on the basics of nuclear science and its applications. Like the atom that is filled with great energy and potential, the future prospects of nuclear science and technology in the Philippines remain bright as day as the country continues to cooperate with the IAEA. Through its contributions in agriculture, industry, health and medicine, environmental protection, nuclear safety, and safeguards and security, it is PNRI's mandate to continue serving as the beacon for the country as it moves forward with nuclear science and technology.
Gusto mo bang malaman kung ang bahay mo ay nakatayo sa isang fault line? Nais nyo bang masigurado na ang tinitirhan ninyo ay nasa isang quake zone? Huwag na mangamba dahil ang ating mga fault finder mula sa Philippine Institute of Volcanology and Seismology of PHIVOLCS ay palagi lang nasa ating tabi 24/7 upang magbigay impormasyon, babala at paghahanda upang maiwasan ang pinsalang maaaring idulot ng lindol. Kilalanin sila dito lang sa aming docu.
Yung mga napuntahan namin are not the common places that most people who love to travel goes to
less
or
beaten
reach
paths.
yun.
Yung dangers, kasi habang nandun ka sa slope, steep slope na gano'n, tapos biglang lilindol na gano'n, so mapipil mo siya. Kasi nangyari yan sa amin, yung isa sa mga fieldworks namin. So habang nag-interview kami ng kapitan sa Bohol, and kahit kung saan negros natin, So habang nag-i-interview kami, nag-educate, biglang lumilindol. So,
Aftershocks.
yun yung mga dangers din.
Actually, yung word na fault finder, ang nag-coin yan kasi isa yung director namin. So, si Sir Renato, yung director. Kaya niya tinawag na fault finder kasi kami yung naghahanap ng mga active fault. Sa totoo lang, marami kaming ginagawa. So, hindi lang yung paghahanap ng fault o pagmamapa. So, pero ang main na ginagawa nga namin is yung yun, mapping ng fault at saka iba pang hazards na related sa earthquake. Minsan, nadadamay din sa volcano. So, day to day, sa isang taon na lang, pag-usapan natin, yung sa isang taon may mga projects kami, kailangan namin produce kunyari ng hazard map sa isang area. So, kung fault hazard dyan, so yun yung focus namin. Kailangan siyang matapos. So, from start, yung aming method, simulan yan hanggang sa matapos siya at i-approve at saka ilabas sa tao.
Halimbawa sa field, no? Field work kami. Halimbawa may lindol na nangyari. Tapos papadala kami doon. Nakikita kasi namin yung fears din ng mga tao, yung takot nila. So, kailangan namin, parang it's not just yung physical side, yung science side na ginagampanan namin sa field, especially kapag may mga lindol. Pero yung social science side na kailangan mo silang parang i-allay yung fears nila and kailangan mo silang kausapin personally na huwag kayong matakot, ganito lang po yung nangyayari sa kalupaan natin. Ganun. So kailangan mong yung science part na technical part, kailangan mong ibahagi sa kanila such that maiintindihan nila in a layman at mawawala yung takot nila or kung hindi man mawala, ma-minimize yung takot nila. So, yan, isa yan sa mga challenges. Hindi man siguro sobrang hirap, pero it's really one of the challenges that we face pag nandun kami sa field work, especially pag may mga emergency situations.
Ito yung may event na may earthquake na may earthquake. Pero
So, parang may quick response.
at least ito, alam mo talagang dangerous andyan yung lindol, may aftershock. Pero iba pa yung hirap ng before, preparing the hazard maps pa lang. So, iba yung, kung nandito lang kami sa opisina, okay lang. Kasi aircon, sige, interpret, maduduling ka lang. Pero yung pag lumabas na kami ng field, kasi we just don't stop with, eto na, na-interpret na namin. We have to go to the field and verify.
Ang fault ay in Tagalog, no? Biyak siya yung bitak sa lupa. Meron pa yung bitak na pinag-uusapan natin, malalim yan. So yun yung parang yung weak na part ng earth natin, kung saan nagbabanggaan yung dalawang parte ng ground together or nagbabanggaan, may naghiwalay, tapos meron nag-slide naman.
Kumbaga, nagkikis-kisan. Nagkikis-kisan yung mga bato. So, yung fault na sinasabi, hindi talaga siya yung, di ba yung, pag naririnig kasi ng mga tao, fault finder, parang you're being critical or something. Pero sa amin, in a geological sense, naghahanap kami ng mga, kumbaga, weak zones sa Earth.
Na pwedeng maging source ng earthquake.
Sa ngayon kasi, para lang malaman ng ibang tao, no? Ngayon, ang sanay ang public, ang mga madla, is to look at Google Earth images. Kasi nakikita na nila yung bukungan ng bahay nila, yung kalsada. Pero noong time na wala pa itong Google Earth at wala pa tayo access sa internet and all of this sa mga digital na mga imaging, ang ginagamit talaga is topographic map. Ito, naka-reflect dito yung contour or yung elevation ng lupa natin. Tapos sa mga marunong makaintindi nito, ang mga sundalo, kami sa mapping, I think civil engineers, geographic engineers, marunong sila umintindi nito. Alam namin kung alin yung mataas na lugar, alin yung flat, alin yung mukhang may deformation, etc. So, doon namin pinaplot yung mga nai-interpret namin from satellite imageries or mga aerial photos. Yung aerial photos, ito yung basehan ng paggawa ng topographic maps natin noon. Ngayon, pag na-interpret na namin to, nalapatan na namin ng tamang mga hazards, lalabas na yung hazard map natin. Pero ang base map namin na ginagamit yung topographic maps. Pero minsan naman, pwede mong ipatong yung hazards. Ngayon, ginagawa namin minsan sa satellite imageries, pwede namin overlay. Kasi nga, meron na tayong GIS. Pero nung unang panahon, yung mga mas matanda, yung mga sila director, yung panahon nila, ano siya, ang ginagawa nila, talagang hand-drawn yung maps. So, from yung hazard maps, hand-drawn nila, pero ang basis nila, topographic maps na ginagawa ng NAMRIA. So,
Bali, basically, yung topographic map, siya yung parang flat na sa papel, representation ng mga elevation natin sa Earth. So, pag naging hazard maps na yan, nandun na yung fault, kung fault hazard ang pinag-usapan natin.
okay.
Nandun na yung, kunyari, liquefaction o yung ground shaking, ipinapatong na doon. So, yun yan.
Parang mas madaming ginagawa kasi sa desktop before going to the field. Kasi
Dapat prepared
i-interpret
ka.
mo na siya eh. So sa map, meron ka nang mapoproduce na active fault map. And then, kailangan mo lang siyang i-verify dun sa field kung nag-exist ba talaga itong landform na to, totoo ba na merong yung river ay offset, i-verify mo siya sa field.
Para ano din lang, mas maintindihan, paano namin hinahanap. Kunyari nangyari na ito years, hundreds of years ago or what, yung recurrence interval. Ang active fault kasi, pag gumalaw siya, di ba yung tinatawag na bumibitak sa ibabaw ng lupa, ground rupture yung term natin or surface rupturing, nag-iiwan to ng langat. So through time, kung hindi na modify yung ground, makikita pa rin dapat namin yung kumbaga sa tao may peklat siya. So yun, makikita namin yung scar minsan na tawag. So yun yung hinahanap namin sa field ng mga evidence. Minsan naman, kunyari ang ilog, alam natin ang ilog ng flow dire-diretso lang siya. Tapos sa mapping namin desktop, merong mga parallel rivers na mapapansin mo, unusually, lahat sila pumaling sa kaliwa. Pero may pattern na kilometers away na mamapa mo, may pattern sila. So yun yung mga tinitingnan namin sa field. Hinahanap namin yung mga evidence na yun. Pag nakita namin siya, okay, alam na natin, nandiyan siya, solid yan, approve na tayo, go. Ganun. Tapos na siya.
Pero meron pa isang yung fault finder dito, yung mga geophysical method naman ginagamit. So yung sila may mga instrumento. So yung instrumento na to parang induced na acoustic wave, induced na seismic wave, tapos parang ano siya, kung baga sa instrumento na ginagamit ng doktor, parang siyang x-ray. Ina-x-ray niya ilalim ng lupa. So kasi kunyari sa ibabaw, so, yung surface, kami pinag-aaralan namin surface, pero pag hindi na siya kita, minsan gagamitan ng instrumento. Yun. So yung isang ibang group yung sa amin, pero still, fault pa rin yung hinahanap nila.
Nung ako nandito, 1989. Tapos nagsimula ako bilang officer dito, that was 2002. Tapos tong subdivision nagko-consist ng 599 houses. Each house merong 6 na household. 2002 to 2004, hindi pa namin nakikita yung mga fault lines na yan. Parang lumabas lang siya nung 2009, mga ganyan. 2009, nakita namin medyo nagbibitak-bitak na yung kalsada. Hindi pa siya bumababa. Tapos, that was 2000, hindi ako sigurado 2010, mga ganon. Nakita namin medyo nag-iba na ang ng kalsada, medyo bumaba na. Tapos, that was the time na meron na nagpupunta dito. para isa-isa ng mga ang CNN, tinignan namin yung mga bahay, doon namin nakita talaga na very, yung sira ng mga bahay. Tapos, doon nila nalaman na karugtong pala to ng West Valley Point. Ayan. Ano pa? Tapos, binisita nga namin yung mga parang dugsong-dugsong siya. Lahat ng magkakahilera ng each block. Tinatawag namin purok. Ngayon, parang dugsong-dugsong na sila. Di ba? Oo. Dugsong-dugsong na sila. So, yun ang nalaman nga namin na merong ang fault line.
The valley fault system is an active fault. No? Alam natin na active fault siya. So, nababanggit-banggit na siya. Ang active fault na to, may ang klase ng paggalaw niya, tinatawag natin na right lateral, pa-horizontal. So, yan. Kunyari, ito yung fault, diba? Bitak sa lupa. So, kunyari, yan yung valley fault system sa isang side, West Valley Fault. Gumalaw siya. Ang klase ng paggalaw niya ay pupunta yung isang part ng block ng land to the right.
So, kung ito yung magkadugtong.
So, kung ito land, kunyari, no, ito yung kalsada, yung blue yung ilog. So, pag gumalaw siya, magiging right. Pero yung valley fault natin, may mga parte dyan na may kasamang pagbaba. Okay, sa field, simple lang talaga yung dala namin. Map, awing working map. So, kunyari, yung trace ng fault, hahanapin lang namin sa field. Tapos mga gadgets, kailangan namin GPS, compass kami, camera, ganun kasimple lang yung bit-bit namin. Rangefinder, oo. So, kung nakikita nyo, nagmamapping kami, dini-document namin sa mapa namin. Yung working map namin yung nakikita namin on the ground. Tapos, syempre kasama doon, nag-i-interview kami ng mga residents. Pagkatapos namin interview yung residents, minsan kinakausap namin sila, pinapaliwanagan kung ano yung nangyayari. So, it's all part na pag kami nag-field work, kahit saan kami mapunta, gano'n. So, mamapahin nyo, kausapin yung taga doon, tapos explain kung ano yung nangyayari. At saka yung ano yung ginagawa namin, yung purpose. So, basically, yung gano'n siya. Ano siya, ito fissure with, ito rin yung coincide with phase ng fault natin. Fault and fissure with. Yung case na to, different to from the case ng mga nasa north na part ng Valley Fault, ng West Valley Fault. Kasi ito, meron siyang tinatawag natin na creep. So gumagalaw siya kahit wala yung ating, walang malaking lindol. Pero yung mga nasa north, yun yung parang pag gumalaw yun, may kasamang lindol, and usually malakas. Yung sinasabi namin na kapag yung structure nyo o yung bahay nakatayo sa fault, pag gumalaw yung fault, kasama yung bahay, gagalaw din siya.
Talagang magkakalindol na ulit. Galing dito yung magnitude 7.2. Ngayon, nakikita na natin yung deformation niya. Mas makikita natin yung sira. Masisira siya eventually. Pagkalindol. Bukod sa may crack ito, masusundan mo yung crack galing sa labas. Dito siya tumutuloy, pero diretso siya dun sa poste. Parang ito na yung isa sa mga pundasyon or ano ng bahay pag mga posts na. So structurally, hindi na talaga safe.
Actually, yung nakikita natin dito, yung mga nakapatong sa fault, kunyari dito sa north part na wala tayong fissuring na nangyayari. Pagka nagkalindol at gumalaw yung fault na yon, ganito yung mangyayari doon. So, pwedeng ganito. Ang number one ano talaga dito, I think yung preparedness, preparedness. So that's why nagkakaroon kami information, education campaign.
For FIVOX part, it's more of the soft measure for FIVOX part. Pero yung iba, ang alam ko after the GMMA 2013 results, itong remapping, if you remember si DPWH, yung Ayala Bridge, di ba, sila retrofitting or inayos nila. So, unti-unti, may mga ganun ng steps I think ever since lumabas din yung MMIers ng 2004. Unti-unti, may mga actions naman yung government. Minsan, tinatanong kami, how prepared are we? Hindi pa rin natin masabi kung Kasi talagang pag andyan na yung malakas na pagyanig, magpapanik at magpapanik ang mga tao. Even kami. Malamang even kami.
Pero nga, yung earthquake drill, actually it's a good practice yun. Kasi parang practice na rin yan pag nagkaroon ng lindol. Doon mo maa-assess kung, ay okay, kulang pa kami ng mga tao sa ganito. Yung committee namin for the medics, kulang pa. Or yung mga tao hindi pa marunong mag-duck cover and hold. Doon nakikita sa earthquake drill eh. So after nung earthquake drill, mayroong assessment dapat yan. At nung next time na mag-earthquake drill, may improvement dapat from the last. So kaya nagiging regular halos yung earthquake drill natin. Para ma-improve na ma-improve. Kasi yung mga tao masanay doon sa gagawin nila. Practice siya. Konti lang kami sa mundo, kaya proud kami na at least gusto kami. And saka hindi siya yung skill kasi na after mong graduate ng college, ng geology course, alam mo na, hindi eh. You learn it through experience, through training. So I think we have gained yung ganong klaseng experience and training para masabi namin talaga na fault finder kami.
Finder talaga yun. Hindi ako yung geologist.
Especially, siguro being with keyboards din. Kaya nagkaroon din ng yung credibility mo as a geologist or as a fault finder. Yun. Kasi otherwise, kung hindi ka naman related sa keyboards, hindi ka nag-work dito sa keyboards, so wala. I mean, hindi rin makikita yung work mo. So we're always attached to the mandates of keyboards. That's why we're called fault finders, and we will be able to leave some legacy.
Siguro yung dedication. How proud are we? Oo, proud. Pero kasi, hindi mo gagawin to kung yun nga, hindi mo feeling na fulfillment. Tapos, kailangan siguro kung sa younger generation, sa feeling ko we have to see yung dedication nila. Kasi talagang tiyagaan talaga to yung pag-delineate, paglinya mo, hours and hours. Minsan inuubo ka na tumutulo na yung uhog mo, sinisip mo, ay may feel ka bukas. Nakatingin kang gano'n sa kota nag-i-interpret ka, pero kailangan mo pa rin siyang gawin.
Pag sinabi namin na ganito yan, yung totoo yung sinasabi namin, may basis. Hindi dagi invento kami. Kaya yung mga umaaway sa amin, may fault dun sa kanila, parang hindi naman po namin yan inimbento. No, that's facts, based on science.
At the end of the day, indirectly man, and unlike yung mga search and rescue workers natin, sila yung direct andun sa scene yan. Indirectly, we know we're saving lives.
Nakakabilib talaga ang DOST. Salamat at nandyan lagi kayo to ensure that our lives are safe and sound. Hindi nyo lang pinagagaan ang buhay dahil sa mga science and technology innovations, kundi ginagawa nyo ring safe and secure ang buhay namin dahil sa mga public and calamity awareness programs na ino-offer ninyo sa bansa natin. Mabuhay kayo! And that's it for today. Kahit anumang panahon ang dumating, babalik kami kay nood lang 11 a.m. to 12 noon, Mondays to Fridays. You can visit our webpage at www.dostv.ph and subscribe to our YouTube channel, www.dostv.ph/YouTube, or follow our Twitter and Instagram page, DOSTvPH. And like our Facebook page, facebook.com/DOSTvPH. Kaya click na at mag-login para lagi tayong magkasama. Dahil weather lang ang laging nandyan, tag-araw man o tag-ulan, hindi nang iiwan kahit sino ka man. Kami ang DOSTv na laging nandyan, may bagyo man, kulog o kidlat, hindi namin kayo iiwan. Dahil laging tandaan, weather is forever.